Have you ever wondered how your favorite apps, like Netflix, Uber, or LinkedIn, handle massive amounts of data in real time? How does your order update instantly? Or your feed refresh with the latest posts from millions of users? A big part of the magic behind the scenes is a technology called Apache Kafka. So, what exactly is Kafka? In simple terms, it's a distributed event streaming platform. Now, that might sound a bit technical, but stick with me. Think of it as a super fast, super reliable central nervous system for data. It lets companies capture data from countless sources as it's created, process it on the fly, and send it wherever it needs to go, all in the blink of an eye. It's the backbone of modern high-performance data pipelines, real-time analytics, and applications that need to react instantly to new information. In the next few minutes, we're going to break down what makes Kafka so powerful and why it has become a go-to tool for the biggest companies in the world. Let's dive into the core architecture of Kafka. At its heart, Kafka is built on a concept called a distributed commit log. Imagine a special kind of notebook where you can only write things down at the end. You can't go back and change what you've written, and every entry is permanent. Now, imagine this notebook is copied and shared across multiple computers, so that if one computer fails, the notebook is still safe. That's essentially what a distributed commit log is. It's a durable, ordered, and fault-tolerant record of events. Now, let's meet the main players in the Kafka world. First, we have producers. A producer's job is simple. It writes data or messages into Kafka. This could be anything a user click on a website, a sensor reading from a factory machine, or a financial transaction. Next, we have consumers. As you might guess, consumers read that data from Kafka. A consumer could be an analytics dashboard, a database that needs to be updated, or an application that triggers an alert based on the incoming information. And what connects the producers and consumers? The Kafka cluster itself, which is made up of servers called brokers. Brokers are the workhorses. They are responsible for storing the data, managing who gets to read and write it, and ensuring everything runs smoothly. They are the guardians of that distributed commit log we talked about. A cluster can have 1, 3, 100, or even thousands of brokers working together. This distributed nature is key to Kafka's power. If one broker goes down, the others can pick up the slack, ensuring the system stays online and no data is lost. It's a team of highly reliable data managers working in perfect sync. So, how does Kafka organize all this data? It uses something called topics. You can think of a topic as a specific feed or category of messages. For example, you might have a user_signups topic, a product_reviews topic, or a payment_transactions topic. Producers write to a specific topic, and consumers subscribe to the topics they're interested in. This keeps everything neat and organized. But here's where it gets really clever. To handle a massive volume of messages for a single topic, Kafka splits that topic into multiple partitions. Each partition is its own ordered log and can live on a different broker in the cluster. Let's imagine our product_reviews topic is getting millions of reviews every hour. Instead of trying to cram all of that into one single log on one machine, which would become a bottleneck, Kafka can split it into, say, 10 partitions. Now, 10 brokers can handle the workload in parallel. Producers can write to these different partitions at the same time, and multiple consumers can read from them simultaneously. This concept of partitioning is the secret to Kafka's incredible horizontal scalability. If you need more capacity, you don't need a bigger, more expensive server. You just add more brokers to the cluster and more partitions to your topics. This allows Kafka to scale out almost infinitely to meet any demand. Now that we understand the architecture, let's talk about Kafka's key capabilities, the features that make it so popular. First and foremost is its mind-blowing throughput. Kafka was designed from the ground up for speed. It can handle hundreds of thousands or even millions of messages per second. And it does this with incredibly low latency, often just a few milliseconds. This means the time between a producer sending a message and a consumer being able to read it is almost instantaneous. For applications like fraud detection or real-time stock trading, this speed isn't just nice to have. It's absolutely critical. Kafka achieves this performance through smart engineering, like using the operating system's page cache and processing messages in batches. The second key capability is fault tolerance. In the world of big data, things fail. Servers crash, networks go down. Kafka is built with this reality in mind. As we mentioned, data in a topic's partition is replicated across multiple brokers in the cluster. Each partition has one leader, which handles all the reads and writes, and one or more followers, which passively copy the data from the leader. If the leader broker fails for any reason, one of the followers is automatically promoted to become the new leader. This process is seamless and ensures that there is no data loss and the system remains available. This is how Kafka can offer guarantees of zero message loss, which is a must-have for mission-critical systems that handle financial data or important user events. The third major capability is scalability. We touched on this with partitions, but it's worth emphasizing. Kafka's architecture allows it to scale out horizontally with ease. Need to handle more data? Add more brokers to the cluster. The cluster can automatically rebalance the partitions across the new brokers to distribute the load. This elasticity is a game changer. Furthermore, Kafka clusters can be stretched across multiple data centers or cloud availability zones. This provides an even higher level of disaster recovery. If an entire data center goes offline due to a power outage or natural disaster, your Kafka cluster can continue running in another location without interruption. This level of scalability and resilience is why companies trust Kafka to be the central data hub for their entire organization. Of course, a powerful platform like Kafka doesn't exist in a vacuum. It needs to connect and work with all the other tools and systems a company uses. This is where the rich Kafka ecosystem comes into play. A core part of this ecosystem is Kafka Connect. Kafka Connect is a framework for reliably streaming data between Apache Kafka and other systems. Think of it as a set of pre-built, plug-and-play connectors. Need to pull data from a PostgreSQL database into Kafka? There's a connector for that. Want to stream data from Kafka into Amazon S3 for long-term storage? Or into Elasticsearch for search? There are connectors for those too. This framework makes integration incredibly simple. You don't have to write custom code for every data source or sink. You just configure the right connector, and Kafka Connect handles the rest, including scaling, fault tolerance, and offset management. This saves developers a massive amount of time and effort. But what about processing the data once it's inside Kafka? That's where Kafka Streams comes in. Kafka Streams is a client library for building real-time applications and microservices where the input and output data are stored in Kafka clusters. It's not a separate processing cluster you have to manage. It's just a lightweight library that you can embed directly into your Java or Scala application. With Kafka Streams, you can perform powerful stream processing operations like filtering messages, transforming their content, joining multiple streams together, or performing aggregations over a window of time. For example, you could use Kafka Streams to build an application that calculates the average rating for a product in real time as new reviews stream in. It offers a simple high-level DSL that makes complex stream processing accessible without needing a dedicated team of big data experts. So, to wrap things up, let's recap what makes Apache Kafka so special. It's not just a messaging queue. It's a complete event streaming platform built on the solid foundation of a distributed commit log. Its core architecture of producers, consumers, brokers, and partition topics allows for incredible performance and scalability. Its key capabilities, high throughput, low latency, and rock-solid fault tolerance through replication make it reliable enough for the most important data. And its rich ecosystem, with tools like Kafka Connect for easy integration and Kafka Streams for powerful out-of-the-box stream processing, makes it incredibly versatile and developer-friendly. When you put all of these pieces together, you get a system that acts as the central nervous system for a modern data-driven enterprise. It's the technology that enables companies to move away from slow, batch-oriented data processing and embrace the world of real-time analytics and event-driven architectures. This is why over 80% of Fortune 100 companies, from banking and retail to tech and telecommunications, trust Kafka for their mission-critical applications. It's the engine that powers the real-time world we live in today. I hope this overview has given you a clear understanding of what Apache Kafka is and why it is such an important technology. If you found this video helpful, please give it a thumbs up and consider subscribing for more content on data engineering and technology. Thanks for watching.